1,000 times in 5 years. 1,000 times in 5 years is 1 million times in 10. We're doing the same thing in artificial intelligence. Now, question is, what can you do when your computer is 1 million times faster? I have a lot to tell you, very little time, so let's get going. Ray tracing, simulating the characteristics of light and materials, is the ultimate accelerated computing challenge. 6 years ago, we demonstrated for the very first time rendering this scene in less than few hours. Let's take a look at the difference in just 5 years. Roll it. This is running on CUDA GPUs 6 years ago, rendering this beautiful image that would have otherwise taken a couple of hours on a CPU. So this was a giant breakthrough already. Enormous speed up running on accelerated computing. And then we invented the RTX GPU. Run it, please. The holy grail of computer graphics ray tracing is now possible in real time. AI made it possible for us to do that. Everything that you saw would have been utterly impossible without AI. For every single pixel we render, we use AI to predict 7 others. For every pixel we compute, AI predicted 7 others. The amount of energy we saved, the amount of performance we get is incredible. We used AI to render this scene. We're going to also use AI to bring it alive. Today we're announcing NVIDIA ACE Avatar Cloud Engine that is designed for animating to bringing a digital avatar to life. It has several characteristics, several capabilities: speech recognition, text-to-speech, natural language understanding, basically a large language model, and using the sound that you will be generating with your voice, animate the face. And using the sound and the expression that you're saying, animate your gestures. All of this is completely trained by AI. It is completely rendered with ray tracing. Everything is real time.
Hey, Jen, how are you?
Unfortunately, not so good.
How come?
I am worried about the crime around here. It's gotten bad lately. My ramen shop got caught in the crossfire.
Can I help?
If you want to do something about this, I have heard rumors that the powerful crime lord Kuman Aoki is causing all sorts of chaos in the city. He may be the root of this violence.
I'll talk to him. Where can I find him?
I have heard he hangs out in the underground fight clubs on the city's east side. Try there.
Okay, I'll go.
Be careful, guy.
None of that conversation was scripted. We gave that AI, this Gen AI character, a backstory. His story about his ramen shop and the story of this game. And all you have to do is go up and talk to this character. And because this character has been infused with artificial intelligence and large language models, it can interact with you, understand your meaning, and interact with you in a really reasonable way. All of the facial animation completely done by the AI. We have made it possible for all kinds of characters to be generated. They have their own domain knowledge. You can customize it so everybody's game's different. And look how wonderfully beautiful they are and natural they are. This is the future of video games. This is the new computer industry. Software is no longer programmed just by computer engineers. Software is programmed by computer engineers working with AI supercomputers. These AI supercomputers are a new type of factory. It is very logical that a car industry has factories. They build things that you can see, cars. It is very logical that computer industry has computer factories. You build things that you can see, computers. In the future, every single major company will also have AI factories. And you will build and produce your company's intelligence. And the factories will be built this way. This translates to your throughput. Well, just now, in the beginning, I showed you computer graphics. Well, it turns out that the friends we met at University of Toronto, Alex Krzyzewski and Suskever and Ilya Suskever and Jeff Hinton, they discovered the continuous scaling of artificial intelligence and deep learning networks and came up with the ChatGPT breakthrough. And the breakthrough, of course, is very, very, very clear. And I'm sure that everybody here has already tried ChatGPT. But the important thing is this. We now have a software capability to learn the structure of almost any information. We can learn the structure of text, sound, images, their structure in all of this, physics, proteins, DNA, chemicals. Anything that has structure, we can learn that language. And then the next breakthrough came, generative AI. Once you can learn the language of certain information, then with control and guidance from another source of information that we call prompts, we can now guide the AI to generate information of all kinds. We can generate text to text, text to image, but the important thing is this, information transformed to other information is now possible. Text to proteins, text to chemicals, images to 3D, video to video. So many different types of information can now be transformed. For the very first time in history, we can now apply the instrument of our industry to so many different fields that were impossible before. This is the reason why everybody is so excited. Let's take a look at what it can do. Here's a prompt, and this prompt says, "Hi, Computex. I'm here to tell you how wonderful stinky tofu is. You can enjoy it right here in Taiwan. It's best from the night market. I was just there the other night." Okay, play it.
Hi, Computex. I'm here to tell you about how wonderful stinky tofu is. You can enjoy it right here in Taiwan. It's best from the night market.
The only input was words. The output was that video. Okay, here's another prompt. "I am here at Computex. I will make you like me best. Sing it with me. I really like NVIDIA." Okay, so this is the word. These are the words. And hey, voice mod, could you write me a song? These are the words. Okay, play it.
"I am here at Computex. I will make you like me best. Yeah, sing it with me. I really like NVIDIA."
Okay, so obviously this is a very, very important new capability, and that's the reason why there's so many generative AI startups. We're working with some 1,600 generative AI startups. There's no question that we're in a new computing era. You don't have to just AI, this generation, this computing era, does not need new applications. It can succeed with old applications, and it's going to have new applications. The rate of progress, because it's so easy to use, is the reason why it's growing so fast. 1964, the year after I was born, was a very good year for technology. IBM, of course, launched the System 360, and AT&T demonstrated to the world the first picture phone. Encoded, compressed, streamed over copper telephone wires and twisted pair, and on the other end, decoded. Picture phone, little tiny screen, black and white. To this day, this very experience is largely the same. Of course, at much, much higher volumes. For all of the reasons we all know well, video calls is now one of the most important things we do. Everybody does it. About 65% of the internet's traffic is now video. And yet, the way it's done is fundamentally still the same. Compress it on the device, stream it, and decompress it on the other end. Nothing changed in 60 years. We treat communications like it goes down a dumb pipe. The question is, what would happen if we applied generative AI to that? Let's take a look.
The future of wireless and video communications will be 3D generated by AI. Let's take a look at how NVIDIA Maxine 3D, running on the NVIDIA Grace Hopper Superchip, can enable 3D video conferencing on any device without specialized software or hardware. starting with a standard 2D camera sensor that's in most cell phones, laptops, and webcams, and tapping into the processing power of Grace Hopper. Maxine 3D converts these 2D videos to 3D using cloud services. This brings a new dimension to video conferencing with Maxine 3D visualization, creating an enhanced sense of depth and presence. You can dynamically adjust the camera to see every angle in motion. Engage with others more directly with enhanced eye contact. And personalize your experience with animated avatars, stylizing them with simple text prompts. With Maxine's language capabilities, your avatar can speak in other languages, even ones you don't know.
NVIDIA 正在使用生成式 AI 来发明新的交流方式。NVIDIA は生成系 AI を用いてコミュニケーション技術に革命をもたらします。
NVIDIA Maxine 3D, together with Grace Hopper, bring immersive 3D video conferencing to anyone with a mobile device, revolutionizing the way we connect, communicate, and collaborate.
Okay, so all of the words coming out of my mouth, of course, was generated by AI. So instead of compression, stream, and decompression, in the future, communications will be perceive, stream, and reconstruction, regeneration. And it can be generated in all kinds of different ways. It can be generated in 3D, of course. It can regenerate your language in another language. So we now have a universal translator. I just talked about how we are going to extend the frontier of AI. But there are so many different applications in so many different areas. Scientific computing, data processing, large language model training that we've been talking about, generative AI inference that we just talked about, cloud and video and graphics. And so let's take a look at the benefit for them. This is a simple image processing application. If you were to do it on a CPU versus on a GPU running on enterprise, NVIDIA AI Enterprise, you're getting 31.8 images per minute, or basically 24 times the throughput, or you only pay 5% of the cost. This is really quite amazing. Now let me talk to you about the next phase of AI, where AI meets a digital twin. Now, why does AI need a digital twin? Let me give you just a simple example. In the future, you would say to your robot, I would like you to do something, and the robot will understand your words, and it would generate animation. Remember, I said earlier, you can go from text to text. You can go from text to image. You can go from text to music. Why can't you go from text to animation? And so, of course, in the future, robotics will be highly revolutionized by the technology we already have in front of us. However, how does this robot know that the motion that it is generating is grounded in reality? It is grounded in physics. You need a software system that understands the laws of physics. Now, you've actually seen this already with ChatGPT. Whereas AI, NVIDIA AI, would use NVIDIA Omniverse as in a reinforcement learning loop to ground itself. You have seen ChatGPT do this using reinforcement learning human feedback. Using humans' feedback, ChatGPT was able to be developed by grounding it to humans and align it with our principles. So reinforcement learning with human feedback is really important. Reinforcement learning for physics feedback is very important. Let me show you everything that you're about to see is a simulation. Let's roll it, please. Everything was a simulation. Nothing was art. Everything was simulation. Now I'm going to show you very quickly Omniverse in the cloud.
Let's take a look at the Omniverse Cloud. So this is, just a web browser, and we're looking now into Omniverse Factory Explorer. It's running 10,000 kilometers away in our Santa Clara headquarters, and we're leveraging the power of our data center now to visualize this factory floor. We've using real factory data from Siemens and Autodesk Revit to take a look. It's a cloud application, so we can have multiple users collaborating. Let's go ahead and bring up Eloise's screen. And we can see that we have these two users in this environment. And Jeff on the left there is going to look at some markup. We have this task to perform. We need to move this object. So we can have Eloise just go ahead and grab that conveyor belt, move it over. And as he does so, you'll see that it's reflected accurately and completely in real time on Jeff's screen. So we're able to collaborate with multiple users. And even in bringing up this demo, we had users from around the globe working on the process. East and West Coast, United States, Germany, even Sydney, and of course here in Taipei to put this together. Now, if we're modifying our production line, of course, one of the things we want to do is add the necessary safety equipment. So we're able to simply drag and drop items into Omniverse and modify this production environment and begin tweaking this and optimizing for performance even before we break ground with construction.
That is so cool. This is in California, 6,264 miles away or something like that. 34 milliseconds by speed of light one way. And it's completely interactive. Everything is ray traced. No art is necessary. You bring everything, the entire CAD into Omniverse, open up a browser, bring your data in, bring your factory in. No art is necessary. The lighting just does what the lighting does. Physics does what the physics does. If you want to turn on physics, you can. And multiple users, as many as you like, can enter the Omniverse at the same time and work together. One unified source of data across your entire company. Just now, it was humans interacting with Omniverse. Humans interacting with Omniverse. In the future, we'll even have a generative AI, and AI interact with him in Omniverse. We could, of course, imagine in the very beginning, there was Jin. That could be a character. That could be one of the users of Omniverse interacting with you, answering questions, helping you. We can also use generative AI to help us create virtual worlds. So for example, this is a bottle that's rendered in Omniverse. It could be placed in a whole bunch of different type of environments. It could render beautifully physically. You could place it just by giving it a prompt, by saying, I would like to put these bottles in a lifestyle photograph style backdrop of modern, warm farmhouse bathroom. Change the background, everything's all integrated and rendered again. Okay, so generative AI will come together with Omniverse to assist the creation of virtual worlds. In the future, whenever you engage a particular ad, it could be generated just for you. Today, it was retrieved. And today, the computing model, when you engage information, it is retrieved. In the future, when you engage information, much of it will be generated. Notice the computing model has changed. WPP generates 25% of the ads that the world sees. 60% of the world's largest companies are already clients. And so they made a video of how they would use this technology.
The world's industries are racing to realize the benefits of AI. NVIDIA and WPP are building a groundbreaking, generative AI-enabled content engine to enable the next evolution of the $700 billion digital advertising industry. Built on NVIDIA AI and Omniverse, this engine gives brands the ability to build and deploy highly personalized and compelling visual content faster and more efficiently than ever before. The process starts by building a physically accurate digital twin of a product using Omniverse Cloud, which connects product design data from industry-standard tools. Then, WPP artists create customized and diverse virtual sets using a combination of digitized environments and generative AI tools by organizations such as Getty Images and Adobe, trained on fully licensed data using NVIDIA Picasso. This unique combination of technologies allows WPP to build accurate photorealistic visual content and e-commerce experiences that bring new levels of realism and scale to the industry.
If you think about it a second, that's an example of a company using digital information that was created in design and using that digital information all the way in marketing. I'm going to show you now how we're going to use Omniverse and AI here in Taiwan. And we're going to use it for manufacturing. Manufacturing, as you know, is one of the largest industries in the world. We're going to use Omniverse to teach an AI. And then we're going to use Metropolis, our AI deployment, edge deployment system, to deploy the AI. Okay, run it.
The $45 trillion global manufacturing industry is comprised of 10 million factories operating 24/7. Enterprises are racing to become software-defined to ensure they can produce high-quality products as quickly and cost-efficiently as possible. Let's see how electronics manufacturer Pegatron uses NVIDIA AI and Omniverse to digitalize their factories. In Omniverse, they start by building a digital twin of their factory, unifying disparate 3D and CAD datasets to provide a real-time view of their complex factory data to their planners and suppliers. In the cloud-native digital twin, planners can then optimize layout virtually before deploying changes to the real factory. The digital twin is also used as a training ground at Data Factory for Pegatron's perception AIs. They use NVIDIA Isaac Sim, built on Omniverse, to simulate and optimize their fleet of mobile robots, which help move materials throughout the facility, as well as the pick-and-place robotic arms that assist on production lines. In the fully operational factory, Pegatron deploys automated optical inspection, or AOI points, along their production lines, which reduces cost and increases line throughput. NVIDIA Metropolis enables Pegatron to quickly develop and deploy cloud-native, highly accurate AOI workflows across their production lines. Omniverse Replicator generates synthetic datasets of PCBA defects, which are too complex and costly to capture in the real world, like scratches and missing or misaligned components. Pegatron then combines the synthetic data with NVIDIA pre-trained models, NVIDIA Tau for training, adaptation, and optimization, and NVIDIA DeepStream for real-time inference, resulting in AOI performance that is 99.8% accurate with a 4 times improvement in throughput. With software-defined factories built on NVIDIA AI and Omniverse, manufacturers can super accelerate factory bring-up and minimize change orders, continuously optimize operations, maximize production line throughput, all while reducing costs.
Did you see that? The whole factory is an Omniverse. It's completely digital. Imagine if you have digital information in your hands, what can you do with it? Almost everything. What you just saw is basically every factory in the future will be digital, of course, first. Every factory will be a robot. Inside the factories, there will be other robots that the factory is orchestrating. We are also going to build robots that move themselves. So far, the robots that you saw are stationary. Now we're going to also have robots that move. Everything that moves in the future will have artificial intelligence and will have robotic capability. We built the entire robotic stack top to bottom, from the chip to the algorithms. We have state-of-the-art perception for multimodality sensors, state-of-the-art mapping, state-of-the-art localization and planning, and a cloud mapping system. Everything has been created. However you would like to use it, you can use pieces of it. It's open available for you, including all the cloud mapping systems. So this is Isaac AMR. It includes a chip called Orin. It goes into a computer, and it goes into the NVIDIA Nova Orin, which is a reference system, a blueprint for AMRs. This is the most advanced AMR in the world today. And that entire stack has been built, and let's take a look at it.
To improve productivity and increase worker safety, factories and warehouses are migrating away from manual forklifts and guided vehicles to full autonomy. NVIDIA Isaac AMR provides an integrated end-to-end solution to deploy fully autonomous mobile robots. The core of the solution is Nova Orin, a sensor suite and computing hardware that enables mapping, autonomy, and simulation. Nova's collection of advanced sensors speeds the mapping process, leveraging our cloud-based service to generate an accurate and detailed 3D voxel map. This 3D map can then be sliced across a plane to generate 2D maps tailored for different autonomous robots that might operate in a facility. With these maps in place, on-robot LiDAR, or cost-effective cameras provide autonomous navigation that works reliably in the most complex and dynamic environments. Isaac Mission Control optimizes route planning using the cuOpt library. To improve operations, developers can use Isaac Sim and NVIDIA Omniverse to create realistic digital twins of the operating environment. This allows fully autonomous robots to be trained on complex tasks entirely in simulation. All operations can be fully validated using Isaac Sim before deployment to the real world. Isaac AMR accelerates your migration to full autonomy, reducing costs and speeding deployment of the next generation of AMRs.
Nova cannot tell that it is not in the reality environment. Nova thinks it is in the real environment. It cannot tell. And the reason for that is because all the sensors work, physics work, it can navigate, it can localize itself. Everything is physically based. Therefore, we can design the robot, simulate the robot, train the robot, all in Isaac, and then we take the brain, Isaac Sim, then we take the brain, the software, and we put it into the actual robot. And with some amount of adaptation, it should be able to perform the same job. This is the future of robotics. Omniverse and AI working together. The excitement in the hard industries, the heavy industries, has been incredible. We have been connecting Omniverse all over the world with tools companies, robotics companies, sensor companies, all kinds of industries. There are 3 industries right now as we speak that's putting enormous investments into the world. Number 1, of course, is chip industry. Number 2, electric battery industry. Number 3, electric vehicle industry. Trillions of dollars will be invested in the next several years. Trillions of dollars will be invested in the next several years. And they would all like to do it better. And they would like to do it in a modern way.